Hello everyone, welcome back to my channel. My intuition chemistry for computer science engineering stream, Visheshwara Technology University, subject code 22 CHES1222. This is a module 1 part 2 video which includes important points as well as the questions indicating the RBTL revised Bloom's taxonomy level as well as the answer. In my previous video I did had two mistakes. The subject code was a mistake, presented as 22 CHEE, and it was only Bloom's taxonomy level was there. Now with this video onwards, revised Bloom's taxonomy level only considered. So previous class I covered sensors, introduction, working principle, application of conductor metric sensors. This is the whole syllabus of module 1. In this particular class video I am covering the electrochemical sensors, thermometric sensors and optical sensors. Electrochemical sensors. Okay, so point number 1, that only indicate the number of points. There is nothing like one is mentioning, just to differentiate different points. I put 1, 2, 3, 4. Okay, so point number 1, it says electrochemical sensors use an electrochemical reaction to detect and measure the concentration of an analyte in a sample. So electrochemical reaction. Electrochemical means it involves movement of electrons as well as it involves the chemical reaction. Usually it is the redox reaction. Okay, so this type of redox reaction, electrochemical reactions, when it happens, it will be detected, and the concentration of the solution, what is the strength of the solution or the analyte in the sample. Analyte means the one which you want to measure. The element which you want to measure, we call it as analyte. It may be ion, it may be molecule, it may be charged particles that we want to analyze its concentration. It can be measured. They typically consist of 2 or 3 electrodes immersed in the sample, and the chemical reaction at the electrode generates a measurable signal that is proportional to the concentration of the analyte. Okay, usually minimum 2 electrodes are there. Sometimes a third reference electrode also will be used. 2 electrodes, one act as the anode or cathode, and the third one as a reference electrode. So minimum 2 or 3 electrodes are used in electrochemical sensor. There are different type of electrochemical sensors that will come in the next slide. The signal which is generated in that sensing device, that it directly proportional to concentration of the analyte. How much concentration of the, what is the concentration of the solution, that they are directly proportional. There are three main types of electrochemical sensors, mainly potentiometric sensor, amperometric sensors, and conductometric sensors. Potentiometric sensors, they measure the potential difference between two electrodes in the presence of an analyte. Potential difference means we know every material has its own energy levels. If it is connected to another material, say mainly if I take the example of metals, that is very easy to understand. If I tell about other materials, their the potential will be very less to calculate. So metals, we use it as the electrode, mainly platinum electrode, or other electrode as a silver electrode. We use different type of electrode. Electrode means it is a metal only, a metal rod, which is we call it as an electrode. When it is used in electrochemical cell or in that type of setup, when we use that electrode, a metal rod, we call it as an electrode. If two metal are connected in contact with each other through a wire, when they are kept in contact through a conducting medium, then there will be a potential difference. The two metals will not be, two different metals may not be having the same energy level. Or if when it is passing through a conducting medium, if the concentration of conducting medium is entirely different, then there will be an energy difference will be there. That can be measured. Whenever there is a difference in energy level, they try to overcome, they try to nullify it by the movement of electrons. So such type of measurement we call it as potentiometric measurements. Amperometric sensors measure the current generated by the electrochemical reaction at the electrode. When an electrochemical reaction takes place near the electrode, when a current is generated, that is measured in terms of amperes, therefore we call it as amperometric sensors. Conductometric sensors, they measure mainly the change in electrical conductivity of a solution or the analyte. Analyte means it is a solution in which we want to analyze it. There is a change in the conduction when there is a chemical reaction takes place. If at all any change in the conduction, not only chemical reaction in the atmosphere or everywhere we want to measure, there will be always some or other chemical reaction happening in the atmosphere. Also we know every day, every second there is one or the other chemical reaction is happening. New molecules are getting formed, not entirely new, the molecules are getting in contact and they are getting reacted. So conductivity measurement, mainly it is done in solution form. We measure the change in conductivity of the solution with the two electrode, mainly platinum sheet or platinum electrodes are used for the conductometric sensors. Electrochemical sensors have several advantages over other type of sensors, like they are typically small, portable and easy to use, and can provide fast and accurate measurements of the concentration of an analyte in real-time measurement. They also have a wide range of applications in many fields, including environmental monitoring, medical diagnostics, industrial process control, etc. There is nothing to explain, straight away the sentence is given. The performance of electrochemical sensors can be affected by several factors, including the composition of the sample, design of the sensing element, and the calibration of the sensor. Composition of the sample means what different elements are present, what range, what composition, what in what ratio they are present, that we call as the composition of the sample. Design of the sensing element, how we design that sensing element, the electrode, how it is designed. It may be a rod type, it may be a sheet type. So these different designs are used. Depending upon the design, the sensing will vary. And the calibration of the sense, how we calibrate the entire device, the sensor device. Based on that, the performance of electrochemical sense will be affected. Careful attention to these factors is necessary to ensure accurate and reliable measurements. As the field of electrochemical sensor development continues to advance, new sensors with increased sensitivity, selectivity, and durability are being developed for a wide range of applications. For example, nanomaterials, microfabrication techniques are being used to create sensor with a higher surface area, increased sensitivity, and faster response time. Nanomaterials, that is a newer material formed having the relative size in the nano range, that is 10 to the power minus 9. That much very small materials if they use. Smaller materials if we use, they have more surface area. So we call it as surface to volume ratio. In the given space, there will be more surfaces which are active if it is a nanomaterial. If it is a bulk material, big material is the kept, only this much surface is there. If there are in the nano size, so many surfaces, all the surfaces are there for the sensing. Therefore, nanomaterials, usage of nanomaterial and microfabrication, the fabrication of the sensing device from a macro fabrication, that is normal or what is visible to our eye. When it go to the micro level fabrication techniques, since it is available, more surface area, more sensitivity, faster response times are available nowadays. First question, describe the basic working principle of an electrochemical sensor and provide an example of a common electrochemical sensor. The revised Bloom taxonomy level for this question is level 2 question. Answer. The basic working principle of an electrochemical sensor, it is based on the measurement of an electrical signal generated by an electrochemical reaction at the surface of an electrode. Therefore, since it is electrochemical sensor, there should be an electrochemical reaction which is happening in the solution, and it should be near to the electrode, so that the electrode will sense that and give the accurate results. In most cases, the electrochemical sensor consists of two electrodes, a working electrode and a reference electrode immersed in a solution containing the analyte of interest. Okay, so mainly it consists of two electrode, a working electrode which will measure the change in the electrochemical reaction, or change in the ion concentration, or change in the any changes which is needed, that will be indicated or measured by the working electrode, and with the reference to another electrode which we call as the reference electrode, you will get the result, but the potential reading will be measured. A potential is applied between the two electrodes which causes an electrochemical reaction to occur at the surface of the working electrode. The resulting electrochemical signal is then measured and used to determine the concentration of the analyte in the sample. Okay, so it's very simple. Two electrodes are used. One electrode is working electrode, the other electrode is a reference electrode. Reference electrode means whose the potential value is constant and it is known. So one electrode it is having constant value, the other electrode which will be measuring the change in electrochemical reaction, and when it is connected to a voltmeter, the potential value will be generated, that we call as E cell, EMF of the cell. If you know the EMF of the cell, we know it is a E cathode minus E anode. So based with that equation, we can find out what is the potential generator or developed at the working electrode. Based on that, we can measure the we can analyze the analyte. One common example of an electrochemical sensor is the glucose sensor used in blood glucose monitoring for people with diabetes. In this sensor, the glucose in the blood reacts with an enzyme on the surface of the working electrode to produce an electrochemical signal that is proportional to the glucose concentration. Okay, straight away sentence, there is no complication here in this. Okay, sensor glucose in the blood reacts with enzyme. Okay, that sensing device, it has got enzyme attached to that, and when blood comes in contact with that enzyme, there is a reaction happening. That is a redox electrochemical reaction. It will be measured by the sensor, since there is a change in the enzyme behavior, that will be measured, and it will be connected to the device. Based on the data available there, it will give what is the glucose level concentration in our blood. Exact reading it will be given, since if it is if the glucose sensor it is well calibrated. Now glucose sensors are very common in day-to-day life. The electrochemical signal in the converted into glucose concentration reading and displayed on a monitor or other devices. So that is one of the example. This type of electrochemical sensor is commonly used in home blood glucose meter, continuous glucose monitors, and other medical devices. Another question: analyze the factors that can affect the performance of electrochemical sensors and how they can be addressed. So the level of the question is 3. I'll be considering a few level 2 question, more level 3 question, and even very few level 4 question. Level 4 questions are considered to be a little bit tougher question. Level 3 questions are a little bit complicated, and level 2 are comparatively easy. Level 1 questions usually nowadays we are not, a teacher will not put a level 1 question, but that is by hearting definition, or by hearting things will not be something the student has to analyze or comment. Like that questions will be more. Therefore one student can always expect level 3 question to level 4 question in main exams. There are several factors that can affect the performance of electrochemical sensor, including composition of the sample, the design of the sensing element, and the calibration of the sensor. Okay, so analyze the factor that can affect the performance of electrochemical sensor and how they can be addressed. There are several factors which affect. We'll see one by one. The composition of the sample can affect the electrochemical reaction at the electrode, leading to inaccurate measurement. Okay, if the sample what we are measuring, if the composition is drastically changing without the expected reaction, unexpected reaction is the composition is changing, or is that any change in composition, then that will affect the reaction and it will give the inaccurate measurements. That is the first point. This can be addressed by using appropriate sample preparation techniques such as filtration or dilution to ensure that the sample is homogeneous and free from interfering species. That means when we prepare a sample for the analysis, mainly this is done in chemical industries or in laboratories. When we prepare the sample to measure, we have to filter it properly. Filter it means the unwanted things has to be removed completely, or it has to be diluted properly. A very concentrated solution may not produce the result properly. A proper dilution means adding water, distilled water mainly. A proper dilution can also be done based on the sensing ability of the device. Otherwise it will be disturbed, and it should be homogeneous. Homogeneous and heterogeneous difference, homogeneous means it consists of only one phase. Heterogeneous means two more phases are there. Therefore there will be always a variation in the composition that will interfere the result. The design of the sensing element can also affect the performance of sensor. For example, by influencing the sensitivity, selectivity, and response time of the sensor. This can be addressed by using appropriate electrode material, optimizing the geometry of the sensing element, and incorporating signal amplification or noise reduction techniques. Okay, so we have to choose the best material. Material means the electrode which we use, the material which is chosen has to be having maximum efficiency of detecting, of sensing. Geometry of the sensing element has to be checked. Then amplification of the signal which is generated, and reduction of the noise, and all will affect the entire device. I'm not talking about entire device, a sensing device, not only an electrode or that electrochemical setup. Entire device, the amplification, signal amplification, noise reduction, all this has to be considered. Finally, the calibration of the sensor is crucial to ensure accurate and reliable measurement. It has to be calibrated properly. Calibrator means with a non-solution, it should give the exact reading. Then we call it as a calibrated one. Always it should give the same reading, which reading that we know. Suppose a given solution, it's the reading, it should come 3. Means if you connect the sensor to that, it should indicate 3 only. Exactly. Without any more variation, that we call as we are getting it calibrated. By carefully addressing these factors, electrochemical sensors can provide fast, accurate, and reliable measurement of sunlight in wide range of. Okay, next question. Question: evaluate the advantages and limitations of electrochemical sensors in comparison to other types of chemical sensors. At the level of the question, it is 3. Answer. Electrochemical sensors have several advantages and limitations compared to other types of chemical sensors. There are many advantages. So starting statement. One major advantage of electrochemical sensor is their high sensitivity and selectivity for certain analytes, which allows for accurate and precise measurement of small changes in concentration. Okay, the one of the major advantage of electrochemical sensor that they have very high sensitivity, they have high selectivity for certain analyte. Sensitivity means it is very much sensible, immediately it will detect, that is called as sensitivity. High selectivity, it will detect only the thing which we needed, not other material, other component which is present or other element present. Whatever we need, it will select that one, it will highly selectively it will detect it, which allows the accurate and precise measurement of small changes in concentration. They also have a fast response time and low power consumption, making them suitable for use in portable and remote sensing applications. They have fast response time. Within no time, it will give the result. The consumption, power consumption is very less. Therefore, it is used as a portable device. You can carry it to remote places for the sensing applications. However, electrochemical sensors can be limited by factors such as their stability over time, their susceptibility to interferences from other compounds, and the need for regular calibration and maintenance. Over a time, if you use that sensor or keep for a long time, slowly it will start deteriorating or start losing its sensitivity or its sensing power, and it can also react with some other compounds present in the atmosphere, as well as we have to calibrate the device in intervals, and its maintenance also difficult. So these are some of the drawbacks or limitations on electrochemical sensor. They are also generally less effective at measuring analytes that do not undergo electrochemical reactions such as gases or organic compounds. So anything which is not giving proper electrochemical reaction, as mainly the gases or some of the organic compounds which will not give redox reaction or electrochemical reaction, they cannot be measured. Only those selected a few can be measured with electrochemical sensor. Not few, many are there, but still so many gases, so many organic compounds cannot be measured. In comparison to other types of chemical sensors, electrochemical sensors are often more cost effective and simpler to use, making them popular for a wide range of applications in healthcare, environmental monitoring, and industrial process control. Okay, this straight away sentence and nothing else. However, for certain applications such as gas sensing or trace level detection, other types of sensors may be more appropriate due to their higher sensitivity and specificity. So there are still many other new sensing devices than electrochemical sensors, which have better sensing ability than that of electrochemical sensors. So certain applications, certain too much high level of sensing if it is needed, electrochemical sensors are not so advisable. Next point, that is thermometric sensors, something related to temperature. Thermometric sensors are used to measure temperature by detecting the changes in resistance, voltage or current as the temperature of the sensor changes. Okay, so as the temperature changes, either it may detect its resistance change or voltage change or current change. All those can be used to sense it. They can be made from variety of materials, metals, semiconductors and polymers, commonly used in industrial and scientific applications such as temperature control in chemical reactors, quality control in food production, and monitoring of medical equipments. Accuracy of thermometric sensors depends on factors such as the quality of the sensor material, the stability of the sensor's environment, and the precision of the measurement electronics. Okay, straight away sentence, no much complicated things are there. One advantages of thermometric sensor is their high sensitivity to small changes in temperature, which makes them useful for applications that require precise temperature control or monitoring. However, one limitation of thermometric sensor is their susceptibility to drift. Okay, drift volume that I'll explain coming slide. It is there. It's susceptible to drift. Drift means after sometimes it will start forwarding or it loses its power. We call it as drift, which can occur over time as a result of changes in the sensor's environment or properties. Question: what is a thermometric sensor and what are some common applications? So straight away question: what is? So it is a level 2 question. Answer: even some of the questions, if it is what is that, so it will be a little complicated. The level will go to 3 and 4, but here it is a straight question. The question answer type. A thermometric sensor is a device used to measure the temperature. It works by detecting changes in physical property that varies with the temperature, such as electrical resistance or voltages. Okay, so change in physical property. The change in temperature is a physical property, which is calculated in terms of the resistance or voltage. Common type of thermometric sensors include thermocouple, resistance temperature detector, RTDs, and thermistors. These sensors are used in wide variety of applications, including temperature control in HVAC, that is heat, ventilation and air conditioning system, temperature measurement in industrial process, and temperature monitoring in medical equipments. In previous slide, we seen three types of sensors that will explain in the coming next question. It is, I am explaining it in detail. Here HVAC, heating, ventilation and air conditioning. It is given in bracket. System used to use thermometric sensors to measure the temperature of air as it is heated or cooled, as well as to control the temperature of the surrounding environment. Air conditioner. This helps to maintain a comfortable temperature of and air quality within the building. For example, a thermometric sensor might be used to monitor the temperature of a room. Temperature of a room signal the HVAC system to adjust the heating or cooling as needed. They are also used in consumer electronics such as smartphones and laptops to monitor temperature and prevent overheating. What is the difference between a contact and a non-contact thermometric sensor? I didn't explain it here in the answer itself. It will be clear. Two different types, that is contact and non-contact. A contact thermometric sensor, it requires physical contact with the object being measured, while a non-contact thermometric, it does not need a touching or a direct contact. It is not necessary. The detection is done through infrared radiation. So by the word meaning itself, whether it has to be in contact or without contact, it can do the work. Question: how do the thermometric sensor work and what are some common applications of these types of sensors? RBT level 3. Thermometric sensors work by measuring changes in temperature, which are then converted into a corresponding electrical signal. The sensing element of a thermometric sensor is typically made of a material that exhibits a change in electrical resistance in response to temperature changes. The sensing element of a thermometric sensor is typically made of a material that exhibits a change in electrical resistance in response to complications. Here somebody is coming. My concentration is deviating. One common example of a thermometric sensor is the thermistor, which uses a semiconductor material to measure temperature changes. Okay, thermistor. They can also be used in medical applications such as to monitor body temperature during surgery or to detect the onset of a fever in a patient. Okay, temperature. Oh, temperature something it is related to the fever. Yeah. So fever. Yeah, usually the thermometric sensors. Compare and contrast the advantages and disadvantages of using thermocouple and RTDs as thermometric sensor. So we will be explaining what is thermocouple and what are RTDs. Thermocouples are a type of temperature sensor which operate based on the principle of the Seebeck effect, which is the production of a voltage at the junction of two different metals when there is a temperature difference between them. That means if two different metals are kept in contact with each other, if there is a change in temperature, there will be a voltage difference that is will be measured with the Seebeck effect that is used in thermocouple. Okay, so it's a couple. Couple means two together. Thermocouples are made up of two different types of metal wires that are joined at a point called the sensing junction. When there is a temperature difference between the sensing junction and the other end of the wire, known as the reference junction, a voltage is generated that is proportional to the temperature difference between that two points, the reference point as well as the junction. This voltage can be measured and used to determine the temperature at the sensing junction. Simple concept. One advantage of a thermocouple is their fast response time and ability to measure high temperatures. Very high temperature it can be measured. Thermocouples are also relatively inexpensive and can be used in a variety of environments, including harsh industrial settings. That's mainly in chemical industries where the temperature goes to above 1000 degrees Celsius. There, the temperature changes can be measured by using thermocouple. However, they may not be as accurate as other types of the temperature sensors, particularly at low temperature. Low temperature thermocouples are not that much efficient. High temperatures, the temperature differences, not minute changes, a little bit bulk big changes and temperature variation can be measured by thermocouple. They can also suffer from a drift over time. Okay, this I said previous slide, which can affect their accuracy. Drift over time, it is the gradual change in the output voltage of the thermocouple when it is exposed to a constant temperature, which can occur due to variety of factors, including changes in the thermocouple material, the insulation changes, or exposure and consequent corrosion of the metal, because it is a metal which is used. That change in slow changes in the output voltage is due to the drift over time, or due to the corrosion, or the insulation. Some of the part are kept insulated. The insulation, if it is gone, then it happens. Thermocouples have many applications in industry, including in the measurement of temperature in furnaces, engines, turbines. They are also commonly used in laboratory setting and in medical devices such as thermometer. So in most of the engines, the furnace engines means a vehicle is also having engine. A bike is having engine. We need to measure the temperature variation there. Furnaces, turbines, thermocouple is used as a temperature sensor. RTD stands for resistance temperature detector. It is a type of temperature sensor that operates based on the principle that the electrical resistance of a metal wire changes as its temperature changes. When there is a change in temperature, there will be a resistance change in the metal wire. That resistance change is measured, and it is connected to temperature. They are typically made up of a thin wire, often made of platinum, which is wound into a coil and embedded in a ceramic or a glass substrate. Okay, complicated words are there, and they are typically made up of a thin wire, metal wire, mainly platinum wire, which is wounded into a coil. which is made into a coil, wound into a coil, and it is embedded to a ceramic or glass substrate. The substrate which is used is either it is made up of ceramic or glass. As the temperature of the wire changes, so does its electrical resistance. By measuring the resistance of the wire, the temperature can be determined using calibrated formula. There are some certain mathematical formula or calibration formula which is used. The value has to be substituted there, will give the accurate result. One advantages of RTD is their high accuracy, which is often better than thermocouples or the thermistors. Thermocouples which are mainly used in at high temperature. Okay, so RTDs are having a better accuracy than that of thermocouple or thermistor. They are also relatively stable over time, meaning that their accuracy does not drift significantly over extended periods of use. However, they are more expensive than other type of temperature sensors, and they have a limited temperature range compared to thermocouple. They cannot be used for very small temperature change. They cannot be used for very high temperature. The temperature range in which the RTDs are used, that is one of its limitation. RTDs have many applications in industries such as chemical industry, pharmaceutical industry, food processing industry, where precise temperature control is important than high temperature or low temperature. And normal room temperature or near to room temperature, where very exact accurate temperature control, if it is required in chemical industry or pharmaceutical industry or in food processing industry. Not only room temperature, some 100, 200, some within 500, because food processing means sometimes the food cooking itself 100 degrees Celsius it will go. So there we are using RTDs as one of the major temperature sensor. They are also used in a laboratory setting, medical devices, and in aerospace and defense applications. Thermocouples are typically less expensive and have a wider temperature range than RTDs. However, they can be less accurate and stable, and their output can be affected by electromagnetic interferences. RTDs, on the other hand, are more accurate and stable and are less susceptible to electromagnetic interferences. However, they can be more expensive and have more limited temperature range. So that about the comparison. Now next question, explain how the accuracy of a thermistor based temperature measurement system can be improved. How it can be improved. So level 3 question. Answer. Thermistors are type of temperature sensor that operate based on the principle of the temperature dependence of the resistance. Okay, about thermistor is not explained in previous question, therefore here I am giving its explanation. Thermistor is explained here. They are typically made up of a ceramic or polymer material that has been doped with the metal oxides such as nickel, copper or manganese. Metal oxide, oxides of nickel oxide or copper oxide and manganese oxide are added to some of the ceramic or polymeric material as a dopant. Dopant means some material which is added as a small amount as an impurity. Okay, we call doping as adding impurity. Is to ceramic some impurity, some metal oxide like nickel oxide or copper oxide or manganese oxide are added, or to the polymer material these metal oxides are added, a little bit amount is added, and it is used in the thermistor. They are classified as NTC or PTC, negative temperature coefficient or positive temperature coefficient, depending on how their resistance changes with the temperature. NTC have a negative temperature coefficient, which means that the resistance decreases as the temperature increases, whereas PTC, the resistance increases as the temperature increases. One advantages of thermistor is their high sensitivity, meaning that they can detect very small changes in temperature. They are also relatively inexpensive and have fast response time. However, they have a limited temperature range compared to other type of temperature sensors, and their accuracy can be affected by self-heating. Okay, so if self-heating disturbs its accuracy, means the temperature range in which we can use the thermistor, we can guess it. Thermistors have many applications in consumer electronics such as in thermostats and temperature controllers. The accuracy of a thermistor based temperature measurement system can be improved by using a reference resistor to compensate for changes in the resistance of the connecting wires and by using a bridge circuit to eliminate the effect of variations in the power supply. What is so something electronics based explanation. Accuracy of thermistor based temperature measurement system can be improved by using a reference resistor. A reference resistor can be used which will compensate any changes in the resistance of the wire which are used for the connection. And by using a bridge circuit can be used to eliminate any variation in the power supply voltage. Okay, so these are the devices which are used in electronics. Resistors are used to maintain the resistance. Bridge circuits are used for controlling of the power supply voltage. Additionally, using a high resolution analog to digital converter ADC to convert the analog thermistor signal to a digital signal can improve the accuracy by reducing the noise and resolution limitations of the measurement system. Question: compare and contrast thermometric sensors with other types of temperature sensors such as thermocouples and resistance temperature detectors in terms of their advantages and disadvantages. Level 4 question for answer. Thermometric sensors, thermocouples, and RTDs are all types of temperature sensors, but they operate on different principles and have distinct advantages and their own limitations or disadvantages. Thermometric sensor based on the principle of electrical resistance, meaning that they change their electrical resistance in response to changes in the temperature. One advantages of thermometric sensor is that they are very sensitive to small changes in temperature and can provide very accurate reading. However, they may not be as reliable as other types of temperature sensors as their response time can be slower and they may not be more susceptible to drift over time. There will be always a drift over time. It means it will corrode easily, or there will be changes in voltage, changes in the reading. Thermocouples, on the other hand, use two different methods that generate a voltage in response to temperature changes. They are known for their fast response time and wide temperature range, but can be less accurate than other types of temperature sensors, especially at a low temperature. Low temperature, the sensitivity is very less. The temperature changes, it will not measure so accurately. But high temperatures, it is very useful. RTDs are similar to thermometric sensors in that they are based on electrical resistance. However, they use a metal wire with much lower temperature coefficient of resistance than thermometric sensors, making them more stable over time. They also have a higher accuracy than thermocouples, but can be more expensive. They are very expensive, but RTDs are more precise results are given by RTDs with some better temperature ranges. It will work. Because of that, it is not that much cost effective. In summary, each type of temperature sensor has its own advantages and disadvantages, and the choice of sensor depends upon the application requirement, whether it is a lower temperature accurate temperature measurement, or a medium temperature accurate measurement, or very high temperature. Based on the application requirement, we have to use all the three different thermometric sensors. The last topic, optical sensors. Optical sensors are devices that use light to detect and measure physical, chemical, or biological phenomena. They work by emitting light and then measuring the light that is reflected or absorbed by the target object or substance. Any complications? Previous sentence take. Optical sensors are devices that use light to detect and measure physical changes, chemical changes, or biological changes. All these are measured with the help of light. Optics means light. By emitting light and then measuring the light that is reflected or absorbed by the target object or the substance. That means whichever substance we want to sense, to that light is passed, whether how much light is reflecting or absorbing. Based on that, the measurement is done. That is the meaning of that sentence. Common type of optical sensors include photodiodes, phototransistors, and photovoltaic cells. Photovoltaic cells are used to generate electricity from the sunlight. Transistors and photodiodes I explained in detail. Photovoltaic cell I explained in some other classes. That is normal solar cells. Optical sensors have many applications, including in robotics, medical devices, and automotive system. In robotics, the optical sensors can be used for object detection and the navigation of the robot. In medical devices, optical sensors are used for the blood glucose monitoring and the pulse oximetry application. In automotive system, the optical sensors are used for collision detection and lane departure warning. Collision detection means when two vehicles are coming and if there is possibility of collision, it will indicate. Means when if you are sleepy driving the vehicle, then it will indicate there is a collision going to happen. Work up and control your vehicle, or it will also indicate whether we are deviating from the lane in which we are supposed to travel in the road. If it is deviated, then immediately it will indicate that we are getting deviated, because lane there will be marking. Based on that, it will detect and inform. That is mainly for vehicles, vehicle application with optical sensor. Optical sensors can be used in chemical and biological sensing, such as in glucose sensing for diabetic management, or in environmental sensing for detection of pollutants. Optical sensors have advantages over other types of sensors in certain applications, such as in harsh or hazardous environments where they are not affected by electromagnetic interferences. It can be used in environment like very harsh environment, highly acidic environment, high temperature environment, high corrosive environment. We can use optical sensors. The development of optical sensors continues to advance with the use of nanotechnology and other emerging technologies, which can improve their sensitivity and reduce their size and cost. So the improvement in technology, materials, new materials with more surface area, more better materials is there. The size is reduced because of nanotechnology, cost is reduced because of the size. Okay. Question: compare and contrast the working principle of photodiodes and phototransistors in optical sensing applications. Level 4 question. This photodiodes and phototransistors is not explained in the point section. So here in question answer type will explain it. Both photodiodes and phototransistors are semiconductor devices used in optical sensing application, but they operate based on different principles. So semiconductor device uses semiconductors. We know what is semiconductors: conductors, non-conductors, and semiconductors. Okay, so photodiodes, they uses the material which are semiconductors, and they work on different principles. Photodiode work by converting the incoming light directly into a current, which can then be amplified and measured. This is achieved through the use of a PN junction, which creates a potential barrier that separates electrons and holes, allowing for generation of a photocurrent when light is absorbed. That means whenever light falls on that system, there will be two type of semiconductors: P type of semiconductor, N type semiconductor, coupling contact, which forms the PN junction. The depletion layer is formed, PN junction is formed, which will allow only the electron movement in only one direction. Other direction electron movement it restricts, so that when light falls on that device, extra electrons will be generated because of the light energy. The molecule get excited, more electrons will be formed, but they cannot come together and nullify. Electrons cannot go and join with the holes which are present there. That will be separated with the PN junction, and these electrons are taken out from that system. It is measured, and that is called as photocurrent. And based on the how much current is generated, how much light is absorbed, it can be measured. In contrast, phototransistors work by using the incoming light to control the current flow through the device, similar to a traditional transistor. When light is absorbed, it can cause an increase in the number of charge carriers in the base region of the transistor, which in turn leads to an increase in the collector current. So normal traditional transistor, we know what it is. It's a three-terminal one with which controls the middle, the base, it's controlling the base region of thermistor, controlling that movement of electrons. Same way in optics also we can have such type of setup. Base region, it is controlled with the presence of light, or whether light is absorbed or not. Based on that, the movement of electron takes. Overall, both photodiodes and phototransistors are useful in optical sensing application, but the choice of device depends on the specific requirement of the application, such as we need better sensitivity or speed or noise performance. Based on that, we can use a photodiode or photoresistors. What are some of the key challenges in developing high performance optical sensors, and how can these be addressed? Again another level 4 question answer. In the question starts with the what, but the meaning of the question, the what they expect from the question, it is a level 4 question. Level is different. Okay, developing high performance optical sensor can be challenging as it requires addressing several key technical design issues. Complicated sentence. Developing high performance optical sensors can be challenging. Okay, developing a high performance optical sensor, it can be challenging, which needs a different knowledge of technical knowledge as well as design knowledge is required to prepare a very high performance optical sensors. Very good. One challenge is achieving high sensitivity and selectivity, particularly in the presence of noise and interference. Noise means not only noise means not the sound noise only. Any disturbance we call it as a noise. Any disturbance that small disturbance also it will avoid. Any other interference it will avoid. So high performing optical sensors can be prepared by using the newer technology. This can be addressed by optimizing the design of the sensor to minimize background noise, such as through the use of optical filters or optical optimized materials. Okay, so we have to focus the light in such a way that only highly efficient results are obtained. There's no any other background noises are interfering that. And optimize the material, the perfect material which is used for that particular application, it has to be used. That is known as optimization, optimized material. Another challenge is achieving high speed operation, which can be critical in applications such as data communications or high speed imaging. Means it should have a high speed operation, it should work at a fast, whatever light, whenever start it, it should give the reading. This can be addressed through the use of high speed components and optimized signal processing algorithm. Optimized signal processing algorithm, that is a mathematical algorithm or mathematical or computational procedures which are used to extract useful information from signals in a more efficient and effective manner. In addition to technical challenges, developing high-performance optical sensors also require addressing cost and manufacturing concerns. So somebody has to fund, and they have to give the better equipments to do the work, and manufacturing difficulties they have to take care of that. Then even I can develop a very high-performance optical sensors. Just joke I said. It needs so high stability, high performance needed means more costly it will be. For example, using specialized materials or fabrication techniques can increase the cost of the device and limits its scalability. Scalability means losing its accuracy. Okay. To address these issues, researchers are exploring alternative materials and fabrication methods that can improve performance while maintaining cost effectiveness and scalability, such as use of low cost scalable process like inkjet printing or roll-to-roll processing. So many different methods are getting introduced in day-to-day technology, uh, trying to use those technology in and solving the issues. That is one of the research which is going on. Sometimes we think that that particular processing it is not used for this, but we have to think something that whether it can be used for a better improvement to device. Yeah, so here it is optical sensor, high performance optical sensors. Sometimes it will be lower cost method, the method will be it become cheaper, it will not be costly. Overall, the development of high performance optical sensors requires a multidisciplinary approach, that what I said, not focusing only, oh I am this field working, I have to work only this. You have to think about different possibilities which are there, uh, and we need to work it on. I try to connect with this material science. Some of my friends are talking there. Material science, so optics, electronics, and manufacturing, as well as a deep understanding of the specific requirement of the application. Question: how would you evaluate the effectiveness of an optical sensor in a given industrial application? And it's a level 4 question, so you have to be very careful with this. To evaluate the effectiveness of an optical sensors in an industry application, it is important to consider several factors. A straightaway sentence, there is nothing to be explained. First, one must assess the accuracy and precision of the sensor measurement as well as its response time, stability over time. The sensor whichever we manufacture, it should the response time of the sensor should be so accurate. It should give immediate response, and it should have stability over time. Second, one must evaluate the sensor's compatibility with the specific application and any environmental factors that may affect its performance, such as temperature, humidity, and vibration, has to be considered. Additionally, one must consider the cost and maintenance requirement of the sensor and compare these to the benefits it provides in the application. Overall, an effective evaluation of an optical sensor is an industrial application requires a thorough understanding of the technical specification of the sensor as well as a practical understanding of the applicant's requirements and the limitations. How would you design an experiment to determine the optical operating conditions for an optical sensors in a given application? Level 4 question answer. Designing an experiment to determine the optical operating conditions for an optical sensor in a given application involves several steps. Starting sentence. One must identify the key parameters that affect the sensor's performance, such as the wavelength of light used, the distance between sensor and the object being measured, and angle of incidence. Okay, so these are very important point. We should be very thorough with the wavelength of light. Each light intensity varies, the wavelength will vary, so we have to be very thorough with what is the wavelength of light that we have to use, and what is the distance which is from the sensing element to the sensor it is needed, and the light incident angle, the angle of incidence also is very important factor in to when we design a optical sensor device. Next, one must develop a set of test conditions that vary these parameters systematically, such as different wavelength, distances, and angles. Then the sensor's response to each of these test conditions must be measured and recorded using appropriate instruments and data analysis techniques. Once all of the data has been collected, statistical analysis can be used to identify the optimal operating conditions for the sensor in a given application. The experiment should be designed to ensure that the results are reproducible and that any sources of error are minimized, such as by using a controlled environment with stable temperature and humidity. I am just reading. There is nothing to be explained. The experiment should be designed to ensure that the results are reproducible. We have to design the experiment such a way that once if you do the work, what is the result we got, a second time when we do, then also you should give the same exact same reading. Then we call it as reproducible, and that any source of error are minimized. There should not be any error. Is that all the error has to be minimized by doing many trials, and it should be reproducible. And the environment, the environment present there, that has to be controlled. Temperature, humidity also has to be controlled. Oh, explanation was there. I was simply reading. Uh, Overall, designing an experiment to determine the optimal operating condition for an optical sensor requires careful planning, attention to details, and thorough understanding of the principles of optical sensing and data analysis. The one who who work on that should have thorough knowledge on the optical sensing and the data analysis principles. And designing an experiment to determine the optimal operation condition for optical sensor requires careful planning. One has to plan each and everything before starting the work, and they have to give a detailed attention to each and every small changes, variation, things, material used, light used, wavelength used, everything has to be very accurately taken care. Then only high precision sensors can be developed. So subscribe and support me. Subscribe my YouTube channel, support me. My YouTube channel is My Intuition.